Objectives. At the end of the discussion, the students should be able to 1. Identify and differentiate networks and its classifications. 2. Explain the network models and expound each type. Good morning, everyone. I am Dave Lester Didovaliana. Together with Aubrey Seno, we'll discuss about the first topic, the network evolution and fundamentals. First, what is network? A network is simply a group of two or more personal computers linked together in order to share resources, such as printers and CDs, exchange files, or allow electronic communications. Many types of networks exist, but the most common types of network are local area networks or LANs and wide area networks or WAN. These types will be discussed later by Aubrey Seno. There are three classifications of networks, namely topology, protocols, and architecture. First, topology. Topology specifies the geometric arrangement of the network. Common topologies are a bus, ring, and star. Then second is protocols. Protocol specifies a common set of rules and signals the computers on the network use to communicate. Most networks use Ethernet, but some networks may use IBM's token ring protocol. Lastly, architecture. Architecture refers to one of the two major types of network architecture, which is peer-to-peer or client-server. In a peer-to-peer networking configuration, there is no server, and computers simply connect with each other in a workgroup to share files, printers, and internet access. These three classifications of network will be further discussed by the following reporters. Now, let's move on to the network evolution. In 1957, the Advanced Research Projects Agencies, or ARPA, was formed by the US. This agency was formed to form and execute research and development projects to expand the frontiers of technology and science and able to reach far beyond immediate military requirements. ARPA is now known as DARPA, or Defense Advanced Research Projects Agency. The reason for the change of its name is to re-emphasize the agency's focus on defense matters over commercial ones. In 1961, the idea of ARPANET was proposed by Leonard Kleinrock. ARPANET stands for Advanced Research Projects Agency Network. Its sole purpose is to link computers at Pentagon-funded research institutions over telephone lines, shown in the map. In 1965, the term packet was used by Donald Davis. Packet is a term that describes a segment of data sent from one computer to another over a network. The analogy of this is imagine that it is a package filled with things being delivered to another area. The package is what we call the packet. In 1969, ARPANET became functional and the Internet was officially born. The 4 points with lines we see in the map are the initially 4 nodes of ARPANET. These nodes are the University of California at Los Angeles or UCLA, Stanford Research Institute or SRI, University of California at Santa Barbara or UCSB, and the University of Utah. October 29, 1969, at around 10:30 p.m., recorded the first data transmission sent between UCLA and SRI. In 1971, Ray Tomlinson sent the first email, and the foundation for Wi-Fi was laid with the use of AlohaNet. Fun fact, the test message he was sent was QWERTY. or something similar. It is not written in history books, that's why he is not really known that time. He is remembered as the man who picked the @ sign as the locator symbol in electronics addresses. Also, he is the inventor of email. In 1973, Robert Metcalfe developed Ethernet at Xerox PARC, and the first experimental VoIP call was made also. Ethernet is formerly known as Alto Aloha Network. Metcalfe changed the name to Ethernet. He did this to make it clear that the system he had created would support any computer, not just Altos. He chose the name based on the word either as a way of describing an essential feature of the system, which is the physical medium carrying bits to stations. A test VoIP connection was made in 1973 also to officially introduce VoIP or Voice over Internet Protocol technology and its capabilities. And until 1995, it is the first software allowed consumers to make such call. In 1976, the first true IP router was developed by Jeannie Strazizar. She developed it at
Bolt Beranek and Newman Incorporated, or BBN for short, as part of the DARPA-initiated effort.
in 1978. Bob Kahn invented the TCP/IP protocol for networks. TCP/IP stands for Transmission Control Protocol Internet Protocol and is a suite of communication protocols used to interconnect network devices on the internet. TCP/IP will be discussed furtherly by the other reporter later. In 1981, Internet Protocol version 4 or IPv4 was officially defined in RFC 791. IPv4 is the fourth version of the standard that routes internet traffic and other packet switch networks introduced in 1982 by the Internet Engineering Task Force or IETF. IPv4 is the most widely used version of the protocol despite the limitations of its 32-bit address space. In 1983, DNS was introduced by Paul Macapetris. DNS or Domain Name System is the phone book of the internet. Humans access information online through domain names like google.com, facebook.com, and etc. Web browsers interact through Internet Protocol or IP addresses. DNS translates domain names to IP addresses so browsers can load Internet resources. In 1988, details about network firewall technology were published. A firewall is a network security device that monitors and filters incoming and outgoing network traffic based on an organization's previously established security policies. At its most basic, a firewall is essentially the barrier that sits between a private internal network and the public internet. In 1996, IPv6 was introduced. IPv6 is the newest version of Internet Protocol formulated by Internet Engineering Task Force or IETF, which helps identify and
Local endpoint systems.
on a computer network and route online traffic while addressing the problem of IPv4 addresses depletion due to prolonged internet use worldwide. In 1997, the first version of the 802.11 standard for Wi-Fi was introduced, providing transmission speed up to 2 megabytes per second. IEEE 802.11 standard, popularly known as Wi-Fi, lays down the architecture and specifications of wireless LANs or WLANs. Wi-Fi or WLAN uses high-frequency radio waves for connecting the nodes. In the year 2002 to 2004, Web 2.0 was introduced. Web 2.0 are websites and applications that make use of user-generated content for end users. Web 2.0 is characterized by greater use, interactivity, and collaboration, more pervasive network connectivity, and enhanced communication channels. Examples of Web 2.0 sites include Facebook, Twitter, Instagram, and various blogs, which all have transformed the way the same information is shared and delivered. Today, the latest computer network used is Web 3.0. Web 3.0 is the third generation of the internet currently being built, where websites and apps will be able to process information in a smart, human-like way through technologies like AI or artificial intelligence, ML or machine learning, big data, decentralized ledger technology or DLT, and more. Examples of Web 3.0 applications are Brave Browser, Siri, StepN, and more.
A great day to everyone. I am Aubrey C. Sena and I'll discuss the network fundamentals. First is the local area network or also known as LAN. So, nagko-consist ito ng computer network at a single site and inaalaw nito na mag-share ng information, files, and other resources. Also, this has a short propagation delay compared sa other mostly used networks. Typically, nagre-rely ito sa wired connections for increased speed and security. But wireless connection can also be part of it. That is called the Wireless Local Area Network or WLAN. Best example na rito is Wi-Fi router, kung saan connected yung ating mga smartphones, laptop, and etc. So, LAN is a private-owned and managed, katulad na lang sa mga office building, whereas kailangan lahat ay may access files into central server. Even sa school, gumagamit tayo ng LAN, specifically sa library. Ganon. So, for the advantages of LAN, first, resource sharing. This is a great way to share resources since limited number of computer lang yung connected. Mas mataas and mas mabilis yung rate of data transmission. So, next is the simple and fast sharing communication. Mas easy mag-share ng different types of messages dahil sa computer terminal is connected to the same network. Last is cost-effective dahil sa cheaper setup nito since hindi naman kailangan ng maraming wires and other infrastructure. Moving on to the disadvantages of LAN. First, the limitation of geographical region. Somehow, disadvantage ito since single site lang na nako-cover nito or mas maliit na area lang katulad ng offices. Second, privacy broken. Possible na ma-access yung information na natatransmit or na-stored gamit yung same network. Last is the security intruders. Security data. Intruders can take benefits and grab your data if one computer gets a virus. It's easy for it to spread to the rest of the network. So, wide area network or WAN, as the name implies, ito yung pinakamalaki and widest area network. This WAN connection is spread throughout a city or country. Also, ginagamitan ito ng PSTN or satellite medium and cables to build a network that works globally. So, basically, this connects multiple LANs together to allow communication. Now, let's move on to the advantages of WAN. First, area coverage. Since nako-cover po nito yung other parts of the world, mas magiging convenient po ito sa atin, lalo na sa may mga business in different places. Through WAN, mas napapabilis nito yung communication from different countries. And now, global business. Convenient ito para sa mga nagbibuild ng business and napapalago around the world. For the disadvantages, number one, security problems. Compared to a and LAN, mas marami itong security problems, possible na ma-hack or magkaroon ng security hole. Next is the server down and disconnection issues. Since wide area network ito, marami sa atin ang hirap makakonect and nakaka-encounter ng mabagal na internet speed. Last, troubleshooting problems. As one covers numerous locations, resolving problems inside it is challenging. Next is the Metropolitan Area Network, or MAN for short. This is typically far wider than LANs, but smaller than WANs. This used to build high-speed data network for cities and towns, and yung function nito is to connect two or more LAN networks. Pero like what I have said, this network is for cities and towns only. The advantages of MAN is first, network conversion. Since combination ito ng dalawa or more LAN networks, then it can be connected quickly dahil sa rapid connection configurations. Next is speed. Since ginagamitan ito ng fiber optic cables, mas napapabilis ito hanggang 1 GB per second. That's why yung data and information kayang matransport ng mabilis. Now is the disadvantage of MAN. First is the maintenance. Since malawakan din itong network na to, mas mahirap na ma-maintain lalo na kapag malakihang data yung tinatransfer. Second is the security. The risk of hackers attacking a MAN network is far higher than the LAN. So, the Personal Area Network or PAN, ginagamit kapag malapitan lang. For example, the connection between AirPods or Bluetooth earpiece and smartphones. Kahit na anong device na close proximity sa user is mako-consider as PAN. And pwede na din natin itong makonsider sa LAN. Best example is sa ating mga bahay. Moving on to the advantages, one is the no extra space required. Hindi na nito kinakailangan ng wires or space for us to use it. Pwede na natin itong magamit through wireless. For example, sa iPhone to iPhone, in order to exchange pictures or notes, pwede natin magamit yung AirDrop. In that way, less hassle para sa atin ang pagpasa ng data. Next is the cost-effective. Since pwede natin ito magamit through our personal gadgets, then hindi na kakailanganin pa ng wires and such. In addition, there are no additional data charges, making PAN an economical method of communication. Last is easy to use. It is user-friendly since nowadays mas marami na ang may kamay na ang technology such as using phone. And moving on to the disadvantages, first, less distance range. Signal range is maximum 10 meters, which provides limitation for long distance sharing. And next is the costly in terms of communication device. This requires digital equipment, which is another downside of PAN. Example are smartphones, computer, and digital cameras. So, Campus Area Network or CAN linked up different local area networks like in school or business campus. Basically, yung CAN is connected to two or more LANs but within the campus. For example, the university. The library has a LAN and academic building has a LAN. Therefore, those two buildings connect to each other. That makes them a CAN or Campus Area Network. So, the advantages of CAN is first, sharing of data is easy. In CAN, the message is sent once and quickly distributed to all associated departments. Next, this use a wireless connection. CAN use wireless connection to link department and buildings throughout an enterprise. For the disadvantages, one is that maintenance is expensive. CAN troubleshooting and maintenance are costly relative to other networks. Next is the limitation for connecting nodes. In CAN, the connecting between nodes is limited, meaning that a huge number of nodes cannot be connected together. So, last is the Virtual Private Network or VPN. So, yung VPN is nagsasecure ng data na ini-input ng user. And if we use VPN, the user will remain anonymous once we are connected to the web-based service and sites. Best application for this is working from home could need to connect to their company's internet or restricted applications. The advantages of VPN is first, the protection from cyber attacks. As what I have said, sinisecure ng VPN yung private information ng isang user once we used it. Next is it provides anonymity. You may effectively conceal your IP address and encrypt data. Now is the advantages of VPN. First, the device compatibility. VPNs typically support most device and operating system, but there are several operating systems that are not supported. Next is the legality issues. Even though VPN is permitted in most nations, in many nations, private networks, including VPNs, are deemed illegally.
Hello everyone, my name is Isa Frilan Galang, and along with Mr. Alico, we will be discussing network topologies and its classification. So firstly, we will start with network topology. We have here 1, 2, 3, 4, 5, 6 nodes, and we have to arrange these nodes so that we can establish a communication among all the nodes. So pag sinabi kasi natin network topology, it shows how all the networks are linked together. It could be in a different manner, like pa-circular, and we have different types for this. Pwedeng pa-circular na yung node 1, simultaneously connected siya sa table 6, then magre-return. Or pwede din siyang from node 1 to node 3, node 3 to node 5, node 6 to node 4, etc. So, yung buong concept ng network topology is how is the layout of the computer network is done. Network topology. So please do take note that topology can also be viewed as physical and logical topology. When we say physical topology, let's say these first 3 nodes, I can place them on the ground floor, and the last 3 nodes, I can place them on the 4th floor of the building, and the placement of these nodes is what makes it a physical topology. Next, we have logical topology. It is how the data is going to flow from, let's say, this node could be in the first floor, node 2 pwede sa 2nd floor, node 3 could be in the 3rd floor, ground floor, and etc. So, how we will deal with this, yun yung dahilan kung bakit siya nagiging logical, kasi it uses. So, please do take note that topology can also be viewed as physical and logical. So, let's start with the first classification of network topology, which is ang P2P o point-to-point topology. Sinasabi na ito ang easiest of all network topologies. So, bakit? Because it contains exactly 2 hosts such as computers, switches, servers that are directly connected using a single piece of cable or network flow. As you can see here, we have main and branch office linked together, and mayroon silang direct flow of data between 2 networks. Let's then discuss the advantages and disadvantages of P2P topology. So generally speaking, sa advantage, since ang P2P ay may 2 nodes, it would be efficient para sa seamless file sharing. Plus na din yung high bandwidth it has and would be easy to handle and maintain. And for the disadvantage, this is exclusively used for small areas that are closely located, so hindi siya pwede sa wide areas. Since depende din siya sa isang common network, both nodes would be affected if mag-fail yung isa. So proceed tayo sa application ng point-to-point topology o P2P. So, una natin pwedeng maging example dito ay yung sa mga offices, kagaya ng main office to its branch office. They have a point-to-point data link connection. Now, let's proceed sa bus topology. In bus topology, there is a common transmission medium and all nodes are connected to this transmission medium. So, meaning yung mga nodes natin connected sila sa isang transmission medium. So, suppose if node A wants to send a data sa kay node B, then it can send a data over this transmission medium, as simple as that. And take note that the data flow in bus topology is bidirectional, meaning this transition is capable of sending and receiving the data. Next, proceed tayo sa advantage and disadvantages ng bus topology. Since isa lang yung wire cable ng connection niya, so less expensive siya. And if pag-fail yung node, hindi affected yung ibang nodes. Pero sa disadvantages naman, no redundancy, meaning hindi siya bidirectional unlike sa point-to-point na pwede ka mag-receive and send ng data. Since isang wire lang, limited length lang siya and no security in a sense na kailangan niya magbigay ng copy sa lahat ng connected nodes sa network na to. Next is sa application of bus topology. Since pa-linear manner yung network layout niya, maganda siya to interconnect computers and peripherals. And it also is efficient to use in a laboratory or office environment para sa high-speed data transfer. Next is ang ating star topology. So sa star topology, connected sila sa isa't isa, not directly but with the help and with the use of central node. So itong central node natin, it could be a hub or a switch. And kaya siya star topology kasi it create a star-like image. And kagaya sa bus topology, ang central failure po dito sa ating star topology ay ang ating hub or switch. Meaning kapag nag-fail yung hub or switch natin, affected yung mga nodes na nakakonect dito. So, proceed tayo sa advantages and disadvantages ng star topology. Sa advantage, meron tayong easy to design and implement, and we have a centralized administration and it is scalable. In a way that, since meron tayong central hub or switch, mas madali natin mamonitor yung mga nakalink na networks or computers. And dahil sa kanyang design na star-like, mas madali natin siyang ma-identify. And sa disadvantages naman, since may central hub or switch siya, kapag nag-fail yun, affected na lahat ng network. And dahil sa switch and hub, imagine we have a 24 ports. So may 24 din na nakakonected na computer. So panigurado mag-overload yun. And mas mahal siya dahil meron siyang center of connection, which is yung switch and hub natin. So proceeding sa application ng star topology, we can start mostly sa mga business ginagamit ang ganito dahil we have a center hub na wherein they can link their computers to a different printer or other station. And for a practical application, pwede natin halimbawa dito yung smart home hub wherein meron tayong smart lighting, smart home sensors, yung fans, cooling system, door locks. So naka-center siya sa iisang function. Ganun yung star topology. And lastly, for my part, is yung ring topology is also known as bus topology, pero in a closed loop. Meaning it has a peer-to-peer LAN topology. Meron siyang two connection, one to each of its nearest neighbors. Meaning, unidirectional siya unlike sa point P2P na bidirectional. And dadaan sa lahat ng nodes yung ating network flow. Communication pattern is always unidirectional kagaya ng sinabi ko, and lahat ng nodes gets an opportunity to have a copy of the data being transferred in a loop. Now let's proceed sa advantages and disadvantages ng ring topology. Una ay mas better ang ring topology kasi yung bus topology ay palinear yung connection niya and yung ring is pa-circular manner and all the nodes have an equal access sa network or sa data. And sa disadvantage naman, unidirectional siya unlike sa P2P na bidirectional, meaning there's no way para maka-receive and send ka ng data. And no security din siya kasi since pa-circular siya, walang direct destination yung file transfer and lahat ng nodes makakakuha ng copy ng data. So, for the application of ring topology, so yung computers connected sa ring topology, usually or most likely mga school or college campuses, because yung data flow nito ay unidirectional, meaning mas fewer yung chance na magkaroon ng data collision. Meron kasi tayong tinatawag dito sa topology na to, meron token, yun yung centralized niya kumbaga. And kada network ng computer, pwede nila silang magka-token, meaning they have a chance para sila yung makapag-send ng data. And kapag walang gumagamit nito, nasusunod yung flow ng data, which is pa-circular. And this topology also is giving a high data transfer between buildings at a high speed. So, usually nga, makikita natin din siya sa offices, branches, and sa mga school campuses.
For the next type of network topology is mesh topology. In this type of topology, a host is connected to one or more hosts. This topology has hosts that are connected point to every other host, or they may only be connected point to a few hosts. In mesh topology, hosts also act as a relay for other hosts that don't have direct point-to-point connections. There are two kinds of mesh topology, which is the full mesh and partially mesh. So for the first type of mesh is full mesh. Every host in this network has a direct connection to each other nodes. Every node is directly connected to every other node. For partially mesh, not every host has a direct link to every other host. Sometimes the way the connection of hosts is total random. There are times we need to make some hosts more reliable than others. The advantage of this type of mesh is it is pretty easy to find problems with point-to-point connections between every pair of nodes. It can handle traffic because there are two or more network nodes connected. The network will still work because there are other ways of data to get from one place to another. But there are some disadvantage of this mesh topology. This type of network is difficult to run because of how complicated the connection is. The cost of this type of network is high because the more wirings, the more cost or the money will be needed for the wiring. And lastly, each network made is connected to every other network mode. So some of these connections don't do anything important. So that means many network connections will be used more than once. Mesh topology is usually used for some home automation, smart HVAC control, and smart buildings. In real life situation, we can see some automated doors like sliding doors, which is automatically will open for you, or a smart bulb that will turn on automatically when you go inside to your houses. So for the next topology is tree topology. This is the most common type of network topology. It can be referred to as hierarchy topology. This topology is like an extended star topology, and it takes on some of the properties of a bus topology. As you can see on the picture, this tree topology has different layers. This network is divided into three hosts or devices, mostly can see in LAN. The access layer is the lowest, and this is where the computer are all connected. The layer in the middle is called the distribution layer. It helps to connect the upper and lower layers. Lastly, the top layer is called the core layer, which can be referred to as the root of the tree. It is the center of the network. The advantage of this tree topology is it is easy to find errors or faults in a connection. The network can be made bigger by adding secondary nodes. So the ability to grow in this topology is reached. Each part of a star connection gets its own link from the main bus. So if one part fails, it won't affect the whole network. And the disadvantage of this is since many segments are connected to a central bus and our central bus is important part of the network, if one fails, then the whole network is affected. Because this network is big and has many parts, it may cost a lot because of its wirings. A small office is a good example for the application of this topology. A tree topology is often used to connect multiple devices like printers, computers, and scanners. For the next topology is daisy chain or daisy topology. By this topology, all of the hosts are linked in a straight line. Like the ring topology, all hosts except the end host are only connected to the other host. This means that if the hosts at the end of the daisy chain are connected, it shows ring topology. In a daisy chain, each link is a single point of failure. Every link failures makes the network into two separate parts. Every host in between acts as a relay for the hosts that are closest to it. The advantage of this daisy chain topology is it does not require many cables, it is easy and quick to send and receive data, and it is less money in spent on buildings. It is an ideal topology for small networks. And the disadvantage of this is the speed of the whole network can slow down if there are more nodes will be added. It gives the station the ability of both send and receive information. So the computer only needs two transmitters and receivers to send and receive data. The two-way links in the ring daisy chain makes it better than the linear daisy network in many ways. When the ring breaks, transmission happens in a reversible lane by making sure the connection is still good. That's the reason why it is used in Metropolitan Area Network or MAN. For the last network topology is hybrid topology. Hybrid topology is a type of network structure that is made up of more than one topology. The topologies that are made by combining them from many parts of the star, ring, bus, and daisy chain topologies. Most wide area networks, or WAN, are connected using dual ring topology, and most of the networks that connect to them use star topology. And the internet is the best example of a hybrid with the most nodes. The advantage of the hybrid topology is this type of topology takes the best part of the different topologies and puts them all into one. It can be changed depend on your needs. It can be changed in many ways, and it also works very well. But the disadvantage of this hybrid topology is it is a kind of network that costs a lot. A hybrid network is very hard to plan out. To connect one topology to another, the hardware needs to be changed, and most hybrid architectures are bigger, so they need a lot of cables to set up. The financial and banking sectors, automated industries, multinational companies, research organizations, and many educational institutions are some of the most important places where hybrid topology is used. And now, let's proceed to the introduction to network models will be reported by Gorospe. Thank you for listening.
Hello everyone, I'm Kim Gorospe, and today I'm going to introduce to you network models. Let's first start off at its background. Who invented the network model? As you can see on the picture, this is Charles William Bachman. He is an American computer scientist born on December 11, 1924 in Manhattan, Kansas, USA. He invented the network database model in the late 1960s as an improved version of hierarchical database model. What is network model? Network model or network database model is a database model that allows multiple records to be linked to the same owner file. The model can be seen as an upside-down tree where the branches are the member information linked to the owner, which is the bottom of the tree. The multiple linkages allows the network database model to be very flexible. And as an improved version of hierarchical model, network model allows many-to-many relationships. In this slide, we have the network model for a finance department. As you can see, we have the salesman, product, invoice, customer, payment, and invoice line. In this network model, a one-to-many relationship has a link between two record types. Now, in the figure above, salesman, customer, product, invoice, payment, invoice line are the types of record for the sales of a company. Now, as you can see in the given figure, invoice line is owned by product and invoice. And invoice has also two owners, salesman and customer. This is what we call parent-child relationship. And as you can see, one child is linked to two or more owners or parents. Thus, the one-to-many relationship of a network model. In this slide, we have this diagram wherein you can see two boxes which contains agents and clients, and there is a pointer from agents to clients. This is an arrow which indicates the relationship of the agent to the client. In this case, the agents in the first box or the upper box is the owner node, and as it goes down, as it points down using the pointer to the clients, which is expected to be more than one, those clients are the member nodes. And beside the diagram, you can see a 1 and an M, which translates to one-to-many relationships, which is represented by the network model. One or more sets, connections, can be defined between a specific pair of nodes, and the single node can also be involved in other sets with other nodes in the database. This results to the complex structure of the model. At the last part of my report, we're going to discuss the advantages and disadvantages of the network model. First, let's start off with the advantages. Simple concept. This means that similar to the hierarchical model, this model is simple and the implementation is effortless due to the fact that one member node can be linked to multiple owners. Next is ability to manage more relationship types. The network model has the ability to manage one-to-one as well as many-to-many relationships. If you remember our diagram earlier, we have a one-to-one relationship as well as the many-to-many relationship. Next, easy to access data. Accessing the data is simpler when compared to hierarchical model because unlike in hierarchical model where you have to trace for the member node that you're looking for, in network model, since multiple owners are connected to a single member node, you will be able to locate the member node that you are looking for easily. Next, data integrity. In a network model, there's always a connection between the parent and the child segments because it depends on the parent-child relationship. Next, data independence. Data independence is better in network models as opposed to hierarchical models. After discussing the advantages of the network model, we also have its downsides or disadvantages. First off is system complexity. Each and every record has to be maintained with the help of pointers, which makes the database structure more complex. Since we know that pointers are arrows, if we have more arrows in the diagram, it will make the structure more messy, complex, and hard to understand. Next is functional flaws. Because of a great number of pointers is essential, insertion, updates, and deletion become more complex. As I've said earlier, with more pointers or arrows in the diagram, it makes the model hard to understand, which also relates to when you insert a new member node or update a node and even delete a node. It all makes the editing difficult. Next is lack of structural independence. A change in structure demands a change in the application as well, which leads to lack of structural independence. Just like in our second disadvantage, once you change a structure, you cannot definitely change only one part. Since most of the members and parents or owners are connected to each other, once you change a member node, you will need to change the owners that are attached to this member node, which is quite difficult. Last is the incomplete flexibility. Albeit more flexible than the hierarchical model, the network 1 still cannot satisfy all relations by assigning another owner. An example of a relationship that cannot be incorporated in a network model would be self-referencing relationships. This means that part pertains to itself and itself only. Next, we have the two predominant models available for network database model. First one is the Open System Interconnection or the OSI model. And next one is the Transmission Control Protocol or the Internet Protocol model.
Good day, everyone. I am Daing Joseph Christian, and now let us proceed sa transport layer. So, transport layer is the heart of OSI model. So, bakit siya tinawag heart of OSI model? Because it provides transparent transfer of data between end users, providing reliable data transfer services. So, yung main function ng transport layer is to control the reliability of the given link through segmentation, flow control, and error control. So now let us first talk about segmentation. So yung segmentation is a process of dividing a data packet into smaller units. So yung data from the session layer is magta-transfer into transport layer. So yung data is magdi-divide siya into data units which is called segments. So each segments contains port number and sequence number. So the function of port number is to help to direct each segment to the right applications. So for example, sa data unit 1 natin or segment 1 natin is yung data niya is patungo sa Facebook. So yung port number natin yung mag-guide doon para mapunta yung data natin sa tamang application. So which is Facebook. So ganun din dito sa segment 2 natin and so on and so forth. So, yung sequence number naman is to reassemble each segment to form the right data. So, for example, ito meron tayo ditong data unit 1, 2, and 3, itong mga box natin. So, dapat yung numbering niya is data unit 1, 2, 3 pa rin. Hindi siya pwedeng maging data unit 2, 3, 1 kasi mag-iiba yung data natin. So, ayun yung purpose ng ating port number and sequence number. So now we have flow control. So flow control is amount of data being transmitted. So for example, sa ating first picture, we have mobile phone na connected sa ating server. So yung server natin is kaya mag-transmit up to 50 Mbps and yung cellphone naman natin is kaya lang hanggang 10 Mbps. So sa first picture natin, yung server natin is nagtatransmit ng 30 Mbps sa ating phone pero hindi kaya ng phone kaya sa tulong ng transport layer is mag-send yung phone natin ng message sa ating server na hindi kaya na 30 Mbps kasi hanggang 10 Mbps lang yung ating cellphone. Kaya makikita natin dito sa second picture natin na yung server is nag-adjust at binabaan niya hanggang 10 Mbps para sumakto doon sa kayang capacity na kayang i-provide ng ating cellphone. So that's how flow control works. So now let us proceed sa ating error control. So yung error control natin is to help to repeat the data if there are missing files. So based sa ating feature number 1, meron tayo missing file na segment 2 so which is nag-cause siya ng pagiging corrupted ng ating cellphone. Pero sa tulong ng automatic repeat request, uulit yung pag-send ng data natin from the server to cellphone. And then, based sa picture number 2 natin ay nahanap niya na yung missing file at yung cellphone natin is hindi na corrupted. Now, let us proceed sa ating network layer. So, network layer handles the sending of data between different networks. So, yung data natin or data unit natin from transport layer is magta-transmit into network layer. So, yung data units natin or segment natin dito sa ating network layer is tinatawag na packets. So, yung packets is magta-transmit siya from network 1 to network 2. So, that's how network layer works. And meron tayong tatlong functions of network layer. So, we have logical addressing, routing, and path determination. So, sa ating logical addressing, it gives a network device a place where it can be accessed on the network using an address that you assign. So, ito yung tinatawag nating mga protocols. So, uh, ang most na ginagamit dito na protocol is yung internet protocol natin or tinatawag nating IP address. So, ito is itatakel ni Mr. Del Castillo. So, let us proceed sa ating routing. So, yung routing is a methods of moving packets from source to destination. So, yung ating packets is transmitting from network 1 to network 2 and it contains the IP address of our sender plus the default subnet mask which is 255.255.255.0. So in path determination is choosing the best path to deliver the packets. So it's simply evaluating the available path of our packets to the destination. So now let us proceed sa ating data link layer. So this is the second layer of our OSI model. So data link layer handles communication between devices on the same network. So the main function of data link layer is physical addressing. So it is a method of moving frames from source to destination using media. When we say frames, ito yung tinatawag nating data units ng ating data link layer. And when we say media, ito yung mga transmission media natin like LAN cable, optic fiber, or radio waves. So ngayon, alam kong napapatanong kayo kung possible ba na magkaroon ng collision or magkagulo-gulo yung data if yung dalawang sender natin is sabay mag-send ng data patungo dun sa ating receiver since sila ay nasa same network lang. So, ang sagot lang dun is hindi siya possible. Kasi sa data link layer natin is meron tayong tinatawag na Carrier Sense Multiple Access or CMA. This method was developed to decrease the chances of collisions when two or more stations start sending their signals over data link layer. So yung CSMA natin is yung nagsisilbing boundary natin sa mga data natin para hindi tayo magkaroon ng collision doon sa mga sender natin if sabay-sabay silang nagsisend ng data nila patungo doon sa ating sender. So for our last layer or first layer ng ating OSI model, we have physical layer. So from the application layer, mag-send yung ating data patungo sa ating transport layer. And then yung data natin is magdi-divide siya into data unit which is called segment. And yung ating segment is mapupunta sa ating network layer and magiging packet. And then yung packet natin is mapupunta sa data link layer and magiging frame. So the main function of physical layer is to convert the packets into electrical, radio, or optical pulses and transmitted as bits. Kasi itong ating frame, packet, and segment is composed of sequence of bits. So overall sa ating OSI model, so our sender is composing data through application layer, then transmit into presentation layer, all the way down so at our session layer, then transmit into transport layer, network layer, and data link layer. And from there, i-convert ng ating physical layer into different waves. Yung ating bits depende sa transmission media na ating gagamitin. And then from there, sa ating media to signal again, up to bit, pataas naman hanggang sa ating application layer, hanggang sa ma-receive na ng ating receiver yung data na sinend ng ating sender. So that's how OSI model works. So let us proceed sa ating next reporter.
Welcome everyone to my presentation on the TCP/IP suite. Today, we will be discussing the application and transport layers of the TCP/IP suite, which are responsible for enabling communication and networking over the internet. By the end of this presentation, you should have a better understanding of the TCP/IP suite and how it works. Let's get started. The TCP/IP suite is the foundation of the internet and is essential for enabling communication and networking between devices. Without it, the internet as we know it would not exist. Example for in real life situation. Imagine trying to send a letter to a friend in another country without any addressing or postage. The letter would never reach its destination, just like how data cannot be transmitted over the internet without the TCP suite. The application layer is the top layer of the TCP suite and is responsible for enabling applications to communicate over the network. It defines the protocols and standards that applications must follow in order to communicate with each other. Example for in real life situation. Imagine you are trying to send an email to your friends using your email client. When you hit the send button, your email client sends an SMTP request to your email's provider server, asking it to deliver the email to your friend's email address. The server responds by sending the email along with any attachments to your friend's email server. The application layer is what enables this communication to happen and ensures that the request and response are properly formatted and transmitted over the network. The transport layer is the port layer of the TCP/IP suite and is responsible for the reliable transmission of data between devices. It ensures that all the data is delivered correctly, even if some packets are lost or corrupted during transmission. Example for in real-life situation. Imagine you are trying to download a large file from the internet. The file is divided into many small packets, which are transmitted over the internet from the server to your computer. The transport layer is what ensures that all the packets are delivered correctly, even if some are lost or corrupted during transmission. It provides error checking and recovery mechanism to make sure that the entire file is received correctly.
Hi, I'm Lemel del Castillo and I'm about to continue our report about the TCP/IP model or the Transmission Control Protocol Internet Protocol model. So for the next layer, it would be about the Internet layer. It is also known as a network layer. The main work of this layer is to send the packets from any network and any computer until they reach the destination irrespective of the route they take. Layer management protocols that are belong to the network layer are the following. So number 1, routing protocols. Number 2, multicast group management. And last one is the network layer address assignment. So basically, itong internet layer po is nagpa-function po siya as a sender. Since tinatransport niya po or minimove yung mga packets from sources like any network and computer hanggang sa ma-reach niya po yung isang particular na destination. And kinokontrol niya po yun, yung flow na yun para ma-ensure po na yung data is masisend ng mas mabilis and sa mas accurate po na paraan. Also, nagpo-provide din po siya ng internet working, which is a process or a technique na kung saan is kinoconnect po yung different networks by means of using routers or yung mga iba't ibang gateway devices. And dahil nga po dito is nagiging useful po siya and lalong-lalo na po sa mga users when it comes to the data communication. So, next slide po tayo. And next naman is yung ating last layer, which is the network interface layer. It is responsible for adding or removing any link layer protocol header required to deliver a message to its destination. It defines how the data should be sent physically through the network. This layer is also called a network access layer. So, kung makikita po natin, meron po tayong picture dyan na in-attach. And ito po yung order while sending data pababa. And pataas naman po is yung while receiving na data. So, ayan po yung mga na-discuss natin na layers. So, para naman po dito sa network interface layer, ang main function daw po niya is for the transmission of two devices on the same network. And this layer defines how the data should be delivered physically through the network. Included din po dito yung how the bits should be signaled by hardware devices towards a network using different cables like yung mga optical, coaxial, fiber, or yung mga twisted pair cables and marami pa pong iba. So, ayun po yung main function po ng ating last layer. So, in short po, itong dalawang last layer po na na-discuss natin, meron po silang same function which is they uphold the delivery of a message or data towards a particular destination po. And that's it po for the last layer. So, next naman po, since na-discuss na natin yung iba't ibang layers ng TCP/IP model and yung mismong model na yan, i-discuss naman natin or intindihin natin yung mga iba't ibang advantages and disadvantages niya. So, number one, it helps users to establish or set up a connection between different types of computers. So, number two, it operates independently of the operating system. And number three, it supports many routing protocols. So, sa disadvantages naman, TCP/IP is a complicated model to set up and manage. Number two, in this model, the transport layer does not guarantee the delivery of packets. And last one, for the disadvantage, replacing protocol in TCP/IP is not easy. And that's it po. That wraps up our report. Again, we are the group 4. Thank you.